Okay, hey everyone, so new video. So I went on eBay and I got myself this 10mm thick beastly stainless plate, and that is going to sit on there. Because it goes over the edges and everything, it's going to offer a lot of support for this. It's got holes in it because it's a base plate for something, but I got it cheaper than if I'd have had it cut myself and everything, so we're just going to go with it. Right, change of plan. We're going to have to do this centre hole by hand. It doesn't fit in my little baby drill press. I cannot wait to get my proper workshop so I can do all this proper tools and space and get it tidied up. I'm using this shed as like storage and everything at the moment. It's not ideal, but it won't be for much longer. There we go. Slow down. Okay, well that wasn't actually too bad, which is nice. So now we can drill the other ones on the pillar drill or bench drill. Awesome. Hey everyone, so I got this plate on. So now just made some bolts out of some studding and some stainless steel nuts, and ground down one of the nuts to make a spacer, like a bushing, to fill this hole a little bit so I can use smaller bolts. So that goes through there. Right, let's just do this up from underneath. That spacer should sort of almost press in there. And they're not going to be, so these bits thread locked, bottom isn't. I'll do that because I might have to take it all apart yet, but so we'll do that once it's done. But yeah, bolt down the four corners, should look cool. So yeah, we just got this plate mounted, 10mm stainless plate, stiffened all the box up. I can lift this up now and it's rigid, it doesn't flex at all. I'm happy with it. So the next job is we want to make like a sleeve to go over this hex so I can mount a small little worm drive motor, because I want to drive this remotely. Now I've thought about using an old socket, slides over there, then you can, you know, weld this up and make this attached to the motor. But I didn't really want to make it look like it was made out of old, you know, sockets and things. I want it to look professional, so I decided I'm going to make my own part. So we're going to sand cast it. We're going to make a little mould and then cast a part and custom make it. So let's get the sand casting stuff out. So I've just got some clay soil, mixed it with some sand and a tiny bit of cement. I'm just going to make a mould, because I don't want to take this spear valve off, take it all apart, because John wouldn't be happy with me doing that, because it's all gone together, you know, how it's supposed to. So instead of taking it all apart, I'm going to make a mould of this hexagon, and then we'll fill that mould up with concrete, and then we can use that concrete form to create the hexagon in the aluminium when we cast it. So take this Christmas pudding shaped thing and push that down there. Now I'm going to repack this this around here as best I can. We have a hexagon. Just touch it up with my finger. It should be a pretty good hexagon for casting. Okay. So I'm just going to sand cast a little part here. I need to make a little little adapter to adapt onto the turbine to drive the spear valve. So we're going to sand cast a little part. So just going to make a tube down through the middle of this sand here. Down to the bottom. Wiggle and pull it out. Look down there, Doc. That's going to be the, it's going to make us a aluminium cylinder. We're going to put this hexagon that I've made out of cement, and it is just cement, not concrete, just cement, and that's going to be in there, and that's going to form the hexagon that this needs to bind onto. Okay, so I'm going to fit that in there, and then we'll pour some molten aluminium in it and hope it works. One of the volunteers that came bought me this charcoal that he made, so thank you for that. He wanted to remain anonymous, but yeah, thanks for that. It's getting used. I use it for when I do these sort of things. We're going to get a little fire going in here and we'll melt some aluminium. Crucible in there, and create a bit of heat, just a little blower, so we'll let that heat up a bit, put a lid on it, got some little scraps of alley here, some old offcuts, that's what we use. Right, just gonna put these little aluminium offcuts in there. Okay, well it's all molten anyway. I can't film it too much, it's burning the hairs on my windsock for the white, but we're ready to pour, I think. I'm just going to get the slag off the top. There actually isn't much there, to be honest. Careful now. Thought that might happen. Fuck. Damn it. All the water bubbled out and escaped. Interesting though. Right, we're going to have to try that again, I think. Damn it!
Is it all hot on you?
We made a tin foil that we actually ended up making tin foil, which is quite funny. Yeah. Oh no, I dropped it. Right, we're gonna have to try that again then. We'll have to come up with something a bit better than that. Right, let's see what this did. Just generally too much water. I think the sand's a bit too wet. See, oh, it did start to work as well. Just all a bit too wet. Just all bubbled out. but it did work. It was exactly as I wanted it. That is exactly what I want to happen. And I want a cap on this end, but yeah, it's just too wet. I hope I can get that out. Don't think I'm gonna though. Fuck. So I got my hexagon that I wanted. So there's the hexagon. It just all bubbled up on me, so I'm gonna have to redo it. But I think it's gonna work. Check it out. Got my casting done. Came out okay. I'm just filing it to the right size and stuff now. I've got a bit of air in it here and there, but I think it's gonna work out. Actually worked. Hey everyone, so I've been messing about, tidying this up all day. This is the casting I made. Just about to put a shine on it. Thought I'd show you. Not bad, eh? Handmade part. Give it a bit more of a polish and then we'll test fit it. Okay, check it out. This is what we've ended up with. Turned out quite nice, I think. A few little blemishes in it, but I like the fact that it looks custom made, and I'm pleased with it. I'm pleased with how it's turned out, so that's the main thing. This is our little worm drive motor, tiny little motor, but it doesn't need much force. So let's assemble this. I've put little divots in it. Oh, sorry, out of frame. Little 5mm little drill slots in it, and these screws have got a little nub in that sits in them, so we'll line that up like that and try and locate that. There we go. You can feel it once it locates it. So that's that attached to that. When it's finally positioned, I'll put some Loctite or something on it, but for now it's good. And then this one's got one too, so then that slides over there, nice fit. And then that one sits in there as well, and that's it. How good is that? Looks like it was actually made for it. Oh, are we in focus? Come on, focus. There we go. How good is that? Looks like it was made for the job. So let's go and get a little power supply and see if it drives it. Right then, got a little portable power supply here. Let's see how this works out. Got it turned right down. Just clip them onto there. Obviously these motor needs some sort of bracketry to hold it and stuff, but let's give it a try. There it goes. That's undoing it. Bit of movement, it's not concentric. I didn't have a lathe to do it on. That's tightening. So we'll switch them round. Works good. Yeah, bit of movement in the motor where it's not perfectly concentric to the whole thing, but yeah, couldn't really help that with the tools I got here. But that's working great, I'm pleased with that. So now I need to make a little thing which holds this motor from spinning around while it's moving, and where we can mount stop switches and limit switches and stuff too. And this motor can be controlled really slow, like I can wind this, look, check how slow that'll go. That's at 1 volt. So you can do really fine control of it. Speed it up a bit, all the way up to like nearly 30 volts with it. Good, right? Right, let's figure out how we're going to mount it. Well, I've got a plan. I'm just drilling out. These are stainless steel bolts I had. I'm drilling them out to make them like tubes. They can be like guides. Right, here we are then, this is what I've come up with. It's quite cool. Drilled out 2 long stainless steel bolts, welded on 2 long shank stainless steel bolts to a little plate. They're just welded from the back. We've seen all this other stuff that I made. So I just made the plate in these. Now welded those 2 together, and so those slot over them like that. So that's the guide. So obviously that will be attached like back, you know, with a piece of stainless coming out from this plate somewhere. You know, they'll be welded to that, so they'll be held by something. I haven't got to that stage yet, but let's pretend they're held. So it needs about 18 mil of travel, so about that much travel. So it starts, it's butted up there at the moment. So if we put the power on, it then moves itself back out, wobbles around a bit because it's not perfectly concentric, but works good. I'm pleased with it. Here we are. I just thought I'd show you. One of the grub screws wasn't that tight, so it was moving around a bit more than it does normally. So here we go. It's a bit better now. So yeah, that's how it works. Slides in and out like that. It's going to work really good. I'm very pleased with it. My limited tools. So I'll give you another angle. Just another angle here for you. So this is tightening. It's getting closer. So it's got a slight wobble to it, but I don't have a use of a lathe at the moment. I can borrow my friend's, but he's quite a way away, and I'm quite pleased with how this has worked, to be honest. Well, I was going to call it a day, but I found this little bit of stainless rod that's been knocking about for a while. I thought that would be the perfect thing for this. So I'm just going to just shape this little piece. I'm going to put this little angle in here, like that. Just tacking it together in place. You know, I'm putting something over, shielding this, just tacking it, and then we'll finish it all off after. So let's get that welded on there. Right, sorry about that, the camera stopped recording. So we'll just get a couple of tacks on these. Okay, hey everyone, so yeah, this has actually been a really successful project. I'm really pleased how it turns out. It's actually quite strong. I can flex it a little bit when I put a lot of weight on it, but it is quite strong. I might end up adding a little extra bit here or something, but we'll see. But it's working really well. Let's check it out. Look, so this is going backwards, so you can see the sort of speeds relating to voltage. So that's why I've set you up with the voltage indicator there. So that's at 8. So if I was to run it at 12 volt, that's the sort of speed we'd be looking at, which I think would be quite good. I don't want it to move fast. Fine control is better for this. So at the moment it's just obviously the mechanical side of it. How I'm going to control it, I'm not 100% sure just yet. It might just be manually like this analog system for now. But if there's anyone out there that's got any ideas of how I could control this without getting too complicated, because I'm not really into sitting at a computer for ages and learning how to program stuff and all that. If they think of a easy, quick way of controlling this, you know, put them some comments down. I'm open for ideas. If anyone wants to have a go at designing something for it, there's also going to be 2 other actuators on here. But yeah, get in contact via the comments or via my website. Yeah, really successful project. So we've got a little bit of movement in the motor where this part of cast isn't perfectly concentric to the rest of it, but it's not a big deal, I don't think. If it ends up being a big deal, if there's movement over here or something, we'll have to just remake that part maybe, but that's it. I'll have to make it on a lathe. But yeah, really happy with it. I think it's a very elegant design actually, the way that, you know, the pins just moving in and out. I've seen pictures of engineering companies that have made these, and and they're actually a lot more complicated. I think it's actually a really good design, so anyone out there, feel free to copy it. That's what it's all about. Let me set you up on a different angle and I'll show you a bit closer up. So I thought I'd just show you a quick clip of it going right to the end of its travel, because I can just hear in the comments section people saying that this will be too flimsy and it won't be able to take the torque. So let's just wind this right in. We'll do it slowly because they've got no control at the minute, so it max out the system, but you'll see it tighten right up. There it is. That's tight now. That is tightened right up. So that will be closed off now completely. That's tight there. So that will be where a stop switch is. There'll be a limit switch here. And now let's undo it, because I can hear people saying that motor's too much torque and it's just going to twist that off. Ready? There it is. Little judder initially, that's all. And it works again. So yeah. Good. So here's from a different angle. So you can see pins can slide in and out. So you can see that tiny bit of movement there in the motor as the motor moves around a little bit. I don't think it's going to cause too many problems, to be honest. I think it's going to be fine. I'll just change the direction, just switch the polarity, and that's going in. Successful projects. Yeah, that's going to be the end of this video. Went really well. Sorry I didn't get too much footage of actually making it, because it was I didn't really know what I was doing. I was making it up as I go along, and it's hard to film when it's like that. So yeah, I really hope you enjoyed the video, and like I say, if you've got any ideas for a control system that's not too much for my little brain to figure out, then get in contact via the comments or via my website. Okay, thanks for watching. See you later.